Recording. All right. Good morning. Since it was just yesterday, we're not going to do much of a review. We're just going to jump right into it. And so what we started yesterday was talking about categorical data. Specifically, how can we visualize categorical data, right? That's kind of where we start. How do we visualize something? And so I'm going to bring in this little chunk here. Come on. I'm going to have to spend some time this weekend to figure out how to make it not so slow. Maybe I have too much stuff open or something like that. So I'm going to bring in this data summary. Here we go. So yeah, maybe my memory is full. My brain is full. No, my iPad full. It might be full. Maybe, who knows? Too many notes. Yeah, no, my brain doesn't feel very full sometimes. All right, so what I want to do is I want to introduce a data set that we can talk about, and this data set is available in R, and so you could bring it in and you could have a look at it and you can play around with it. In fact, I think I have some R code for you to work with in the notes here, so I'm drawing a blank. I can't remember if I did or if I didn't, but I guess we'll see. So we're going to use the MT cars data set. So the MT cars data set is the Motor Trend Car Road Tests, which is from 1974. Okay, but it's a really common data set. It has some nice properties. You know, it has a good chunk of variables. It has categorical data. It has numerical data. And so it's a really nice data set to show how to do some basic stuff. Hey, good morning. And so it's focusing on fuel consumption on 32 cars from 1973 to the 1974 models. And so it has 32 observations, which means we've considered 32 different cars, right, on 11 variables. So now when you see this, I want you to imagine, right, your spreadsheet would look something like this, right? So you've got your observation 1, 2, all the way down to 32, right? So it's saying that you've got 32 rows, right? And on 11 variables. So here I'm going to have variable 1, variable 2, oops, say 2, but then I wrote 1 again, and then all the way up to variable 11, right? So you'd have this 32 by 11 grid as your spreadsheet. Okay, and so the variables that we're looking at are listed here. So I'm just going to count them out, make sure they didn't slip across the page here. 1, 2, 3, 4, 5, 6, 7, 8, 10. Maybe it's on the next page. Ha, of course. While I'm here, I may as well grab all of this while I'm here, because it's slow. All right, so let's see here. Zoom out a little bit, try to line that up. So it looks like one list. Haha, I did it. All right. So it's recorded things like the miles per gallon, which of course, if we're talking about fuel consumption, that's going to be probably going to be our response variable, right? If we're talking about, right, so here, so if we're focusing on fuel consumption, right? Then it's likely that the miles per gallon is the response variable, right? I don't know for sure because there hasn't been a research question stated yet. It doesn't have to be, but it's likely going to be the one that we're most interested in, right? And so the miles per gallon is a measurement, and so it's definitely going to be numerical, right? So now we have the skills to be able to say, okay, well, even though we don't know, maybe you do, but we collectively haven't covered how do we analyze a numerical variable, right? But we do know how to summarize a numerical variable, how to visualize it, right? We can make a histogram, and then we can look at things like the 5-number summary and the mean and the standard deviation and all those kinds of fun things. Right, so we know how to deal with a numerical variable, but right now we're focusing on categorical variables. So if we go through the list here, cil is going to be the number of cylinders, right? Even though it's a number, right? This is one of those tricky ones where I think you can have, and I'm going to cheat a little bit, you can have 4, 6, or 8 cylinders, but those are categories, right? And so here, this is going to be a categorical variable. So that's the first one that we're going to focus on and use for this example. Just going through the list, because part of our skills now is we're able to identify whether a variable is numerical or categorical, right? That's your first step, because that's going to tell you which path to go down. So if we look at the displacement, which is in cubic inches, just the fact that there's a unit here tells me that it's probably a measurement, right? And so that tells me that it's likely numerical, right? The gross horsepower, again, is going to be a measurement, right? It's discrete, but it's still numerical, right? I'm pretty sure you can't have a fraction of a horsepower, right? It's either 1 horsepower, which is just 1 horse, 2 horsepower, 3 horsepower, 4 horsepower, right? But that's still numerical because it's a measurement. So I would say this is numerical. DRAT, the rear axle ratio. I don't actually know. I'd have to look into that one, right? And then the weight. So I'm going to just talk about the rest of these because you can keep going, but the weight is going to be numerical. Q-sec is going to be the quarter mile time, right? So time is a numerical measurement, probably in seconds, right? How long does it take to, and I think it's in seconds because of the name, right? How long does it take you to drive a quarter mile? Probably at top speed. VS is the engine, so 0 is V-shaped and 1 is straight. This introduces something called a dummy variable, which we haven't talked about yet. So a dummy variable is when you code something as either a 0 or 1, right? So it's either on or off. So it means you only have 2 possible outcomes used for 2 categorical or for 2 outcomes, right? Just kind of on or off. Right, and so we're going to have numbers in the data set, right? But then it's up to us to recognize that, okay, if I see a 0, it means that you have a V-shaped engine, right? And if I see a 1, it means that I have a straight engine. I don't know what those things mean, but I have the definitions here. And so it really doesn't matter, right? In terms of our analyses, right? And so I don't need to know anything about cars here. That's probably one of the first things you have to learn, is that it doesn't really matter what the data is about most of the time, right? The analyses stay the same, right? So you kind of have to get over that, where I don't know what that is. That's okay, it doesn't matter. And then we've done the same thing with the AM, which is the transmission. So 0 means that it's an automatic and 1 means that it's manual, right? So you don't want to be talking about things like the average of the transmission because it is a categorical variable. It's just been recoded as a 0 or a 1. Gear is the number of forward gears. I would probably call that a categorical variable because you can't have, you know, there's only a set number of gears that you could have. So I would probably call that a categorical variable. And then the carburetors, the number of carburetors. Question, yes. I saw a hand up. Anshul, did you have a question? Oh. All right, that's fine. That's allowed. Maybe it's more of a wave. Hey. Okay, so we're gonna focus on the cylinders, right? The number of cylinders. And so MT cars should be available just in base R. Okay, so how we access MT cars, which is the name of the data set, right? MT cars, I'm pretty sure is just exists in base R, so we don't need to import it. Usually, if you need to work with a data set, often you'll need to import it first, but we're gonna kind of work with some of the base R data sets first. So if you just type MT cars, just like this, right, it should, and then hit enter, it should just run and it should just show you the entire data set, right? All 32 rows, 11 columns. It might be split up across your page depending on, you know, the size of your screen, but it would show you all that data. So now what we're doing here, when I say MT cars $cylinder, what I'm actually saying is go to the MT cars data set and only pull out the cylinder column. Okay, so this is how we're going to reference just a single variable from a huge data set. Okay, so here, MT cars $cylinder. Oh yeah, so you would code, so if you're tossing a coin, typically you would code it as a dummy variable. As soon as you have just a bivariate, so, or no. Bivariate is 2 variables. Binomial? Anyways, it's a binomial outcome, but we'll parking lot that. As soon as you only have 2 outcomes, we typically just code it as a 0 or a 1, so dummy variables. Yeah, so tossing a coin, definitely. Good. Okay, so this, I want to break this up. It says, this is basically saying go to MT cars. Only access one variable, right? Or one column. Right? The column I want is called cell. right? And so this is how you're going to read these. So you need to go to the data set, and then you use the $sign, and it has to be all one word, right? As soon as it's a space, it stops reading, right? And so empty cars $sign cylinder says, go to empty cars and give me just the cylinder, right? And so you could play around with just this, but it should just give you just that one column, okay? And then what we've done is we've wrapped it up in the table function. Now the table function recognizes so there are some databases, so just referring to a question here. So there are some databases that exist in R in packages. So it's possible that you just have to import the package first, or install the package and then access that library. So if there's one in particular, then I can play around with it after, but typically they are stored in packages. If you want just 2 columns, you'd have to use a colon, I think. I think it's a colon. Off the top of my head, I don't want to lead you astray because I don't have it. Exactly. So then after you do install.packages empty cars, and I think maybe there's quotes around empty cars, you'd have to call library empty cars, assuming that's a package. Yeah. But if you want 2 columns, I'm pretty sure it would look like this: empty cars $sign 2, 3 would give me the 2nd and the 3rd column, I'm pretty sure, and square bracket. But I don't want to commit, so I'm deleting that. It's a good question, but it's a little bit more advanced than what I wanted to do. So I'll look into it. I've got it, it's here, but I have to play around with it. Okay, so when we run the table command, it treats our data as a categorical variable, because what we should be doing to kind of summarize categorical variables is use a table, right? And so it's this kind of gross looking table, right? Where you can kind of imagine, okay, so here, these are your categories. And these would be your counts. Okay. So there were 11 out of 32 cars that had 4 cylinders. There were 7 out of 32 cars that had 6 cylinders. There were 14 out of 32 cars that had 8 cylinders, right? And so that's the best possible summary that we can come up with for one categorical variable. Okay, good. So we use the most common summary of a categorical variable is a table, right? And so that's what we saw before. So you would typically look at the table and look at the counts. Summarizes the counts. I'll just throw this in brackets. Summarizes the counts for each category. Yeah. Good. And so we saw the visualization here last day, and I went on and on and on about pie charts. They're no good, blah, blah, blah. So I already did that spiel, right? But in terms of a visualization here, right? We've got the categories down here in the bottom. We're going to focus on the bar graph, right? So here we've got our categories. And then here we've got our counts that make up the height of the bar. So we could take this table data and we could translate it to the actual heights of the bars, right? 11, 7, and 14. 11, 7, 14. Usually, if you have something simple like this, it's easier to just see what's happening in the table with the bars. There are instances where it's going to be important to know the specific numbers, right? Not just the relationships to each other. So then you would opt for a table. But for now, we'll just keep it nice and simple. And then I talked about, and I posted the video that I showed because the sound wasn't very good. Maybe I need to go back and watch that episode again and record it because I couldn't find it anywhere on the internet. But anyways, it's really funny. So, or I think so. So I posted that. Hopefully it works. Who knows? Technology, right? Okay. So here, categorical data, we said we should be summarizing with a table. So here are two tables. Okay, let me just copy. So now when I show you this code, right, it's not going to be as crazy as it was before, right? So here, categorical data is often summarized in a table, right? And so we can make frequency tables of the first two categorical variables, which is going to be the cylinder and the VS, which is the V-shaped engine or the straight engine, right? Referring back to those that data summary. So we've got these tables here, right? And so now it's not so scary when we see empty cars $VS. We just know that we're accessing a different column, right? And summarizing that. Notice that it's a dummy variable, right? And so we have to remember what 0 was. I think 0 was V-shaped and 1 was straight. All right, and then we can look at the breakdown there. Okay. I'll do this whole section. Oh, come on. So we can have a look at what we call a contingency table, which is when we consider two categorical variables against each other, right? How do they relate to each other? So a contingency table looks like this. So how you would generate it. And there are different ways of writing this. There isn't just one chunk of code that's going to generate this. There are actually lots of different ways. I've tried to keep it as simple as possible, right? Which is often not the most elegant way, right? But elegance comes with time, right? And so for now, we're just going to do kind of this really basic way of just saying, okay, I want a table of the cylinders, comma, the VS, right? And so notice that it takes this first section and maps it to the rows, right? And then it takes the second section and maps it to the columns, right? And now we can look at, okay, there's 1 out of 32 cars that has a 4-cylinder engine and is V-shaped, right? So now we're saying, and maybe I'll grab one of these here, right? This says, hey, look at all these arrows. hopefully you can make sense of it later. But this 4 says there are 4 cars out of 32 that have 6 cylinders and what was it? A straight engine. Right, and so we can get a lot of information from this contingency table, right? Raw counts, though, is hard. It's hard for our brain to understand 4 out of 32, right? We don't have that intuition about what 4 out of 32 is, right? And so what we usually do is we should be reporting the proportions, right? And so one thing that I want to highlight is that a proportion is essentially the same as a percentage. And later on, it's going to be considered a probability as well. And so all those 3 P's mean the same thing, right? But over here, the proportion, just to start off there, is the number in a category, right? So 4 over n, which is 32, 4 over 32. So it's just you're dividing them out, right? And just putting them all over 32. And so here, just as a note, that a proportion is a probability, although we're not calling it that quite yet, but we will. And so that's why I want to highlight it. And then I'm going to have is roughly equal to, if I could draw a proper roughly equal to, a percentage. Why is it roughly equal to? Well, it's just because I have to take the proportion and then times it by 100%, right, to get the percentage. But I think if I say 0.45, in your minds, you just convert it to 45%, right? And so we do that pretty naturally already, right? And so that's why it's roughly equal to a percentage, because it's not the exact same value, right? But they're all related. So here, right, a proportion is a probability, which is a percentage, right? Almost a percentage, right? So those all mean the same thing. So how do we make a table of proportions? Let's focus here on the code. So what I've done, okay, is, and what you would have to do, and I've tried to use as clear of comments as I can. Remember, comments in your code mean that, okay, here's a little note to myself for later when I go back and I look here and try to figure out what's going on. So first thing you have to do is save the contingency table. So I have named it sil versus, or sil vs tab, right? I guess cylinder vs is the second variable, and then table tab, but you could call it whichever name you want, right? You could just call it A if you wanted to, but that doesn't really tell you much later on, right? You want to have something that kind of points you towards what it is. And so here, right, we were looking at this contingency table before, right? And so now I've just named it something. Okay, so I've assigned it this name. So now when I type sil vs tab, it is just referring to that entire table. So then I can create a table of those proportions. So I could do a prop.table, okay, which is how we get that proportion, okay, of the original table, right, which is just the contingency table. So notice how I'm referring to this variable, which I created in the line above, right? So prop.table creates this table of proportions. And so now we have a better understanding of how do these categories all kind of relate to each other, right? The easiest thing to point out is the largest proportion is the proportion of 8 cylinders and is it V-shaped engine? I can never remember. Should go back, but my iPad's being slow, so I won't. Right, with 43.75%. So usually when we're talking, we talk about percentages because our brains work that way. But for number reasons, right? So for kind of calculation reasons, we should be using decimals. So the decimal, the proportion in our calculations, right? But when we talk and when we write reports, we often convert them to percentages, right? So here, right now we have this table of proportions that we can talk about, right? And so here, just to kind of reference that same value, right? 0.125 or 12.5% of cars have 6 cylinders and a straight engine. Right, so we can talk about any one of those values, and it just depends on what we're interested in, right? Maybe you want to talk about the category with the least number of cars in it, the most number of cars in it, the most common one, right? It depends on what you want to talk about. Okay. So if we're talking about more than one categorical variable, then we can make a chart for that, right? So often we're not just interested in one variable, which would make one bar chart, right? Often we want to talk about how 2 variables compare to each other. And so there are kind of 2 common options. There are lots and lots and lots of other options, but we could make a segmented bar chart or a side-by-side bar chart. And we've also added a legend in this case. And so I just want to show you, and I've got the code here. And notice, you'll see that I'm only using base R graphics. So I'm using the bar plot command. It's not very fancy. It's just to get the job done. Right? If you have taken other courses where you've used R before, you've probably had to use ggplot, right? ggplot is way more sophisticated, but I didn't want to introduce ggplot as well. So I'm sticking to the base graphics because that's what we're learning about here. Okay. And for most of what I do, I don't really write reports anymore. I did at one point, but now I'm just doing stuff to see what's happening, right? So I don't need it to be beautiful for me. You use ggplot to make a beautiful graph for someone else, right? It's a gift. Okay, so this is a segmented bar chart, which just means that you've broken up and you've shown the total bar, right? So the total height of the bar is the number of cars that have the V-shaped engine, right? The 0 versus the number of cars that have the straight engine. So that's the overall height of the bar. And then, I couldn't figure out how to get this legend to bump up. That's okay. I didn't want to spend too much time on it. So it just puts the legend in a certain spot. You can move it, but I didn't because I didn't want to mess up my code up here beyond what I was already doing, right? And so the height of each bar is just the amount in each category, but then notice how it's broken up. The bar inside is broken up by segments of how many cylinders there are, right? Going from 4 to 6 to 8. Okay. And so we see that there are no 8-cylinder engines that have a straight engine, right? Same information, could be displayed like this, right? And so now we could look at the individual counts in each category, in each cylinder category, right? And so I actually prefer the side-by-side bar chart typically, and often we'll convert these to proportions, right? And so we'll talk about the proportions. But for now, I want to kind of work through this chunk of code here and make sure that it's not so scary looking. This here is just to say put them side by side. Okay, so it looks scary. It just says par mf row equals C1, 2. And so it means that I want the next two images, I want them in one row with two columns, right? And so put the next two images produced next to each other. That's all it's saying. Okay, and so that's how I got them side by side. Otherwise, it would have produced them like this, but that takes a long time. And so I find that that's a really useful chunk of code that I use often, so I'm sharing it with you. Then it says, the first thing I want to do is make a bar plot of that sil versus tab. And now remember that that's the actual table, right? Not the proportions, but the actual counts in the original table that we saved, right? So it needs a table argument. And then the legend, I'm telling it should be the row names of the sil versus tab. You could change it and you could make it the column names, but then you should change the bar plot. And so it was a while ago that I played around with this, and I'm not sure you could change it. So I likely what happened is I made a bar plot of sil versus tab, and then I saw which one was on the x-axis, and then I made the legend whichever was on the in the segments, right? Again, for the second graph, right, the side-by-side bar chart, I'm still using that table of counts, right? So I'm making a bar plot of the counts, and then beside equals true. That's what's going to put these beside each other, right? The side-by-side bar plot. And then the legend, again, is going to be the row names of the sil versus tab. Remember, sil versus tab is this table of counts, and the row names is the number of cylinders. Okay. Good. So a lot of code, but once you break it down, it's not so bad, right? And you can use these chunks to recreate other side-by-side or segmented bar charts. Okay. Usually, we're interested in a numerical variable, right? That's just life. Usually we're interested in these measurements. How do we predict future measurements, that kind of thing. And so usually we want to look at and compare numerical data across groups, right? So now I want to take some numerical variable, miles per gallon, for example, which we said, well, I think that might be the response variable. And how does it compare across the groups, right? So across a categorical variable. So what we can do to visualize that distribution by breaking it up into the categories is we can make a side-by-side box plot. So we've already seen a box plot yesterday. But now I want to break it up and I want to have a box plot for each category. Okay, so how to do that is actually sort of easy. Nothing's easy, right? But relatively easy considering the output that you get. So you're going to use the box plot command. And then what you want to have is you want to have your numerical variable. Okay. Your numerical variable. And then here's the tricky part. this tilde, so this is a tilde, and on my keyboard, it's way up here. It can be hard to find. So it's under my, I guess, escape button. So you'll have to find it on your keyboard. But this is a tilde. Okay. And it just says, so usually we use it in the sense of y tilde x, right? So y on x, for example. So usually we have something like y tilde x, okay, which you can read as y by x, if that helps. Sometimes it doesn't really help, but that's how I read it, right? Or y on x. Means nothing, I guess. It helps me though, I don't know. So now I want to have the miles per gallon by cylinders. Okay, so that's how I read this. All right. Categorical. And so when I see this here, oops. Hey. When I see this, actually, this whole chunk, copy, finally, there. I'm going to read this as make a box plot of miles per gallon by cylinders. Okay. So let's see what that output looks like. It's going to look like this. And I've got a funny there. So now, let's see here. There. We've got the miles per gallon, right? So the miles per gallon is here. So the numerical measurement is here. How about that? And then my categories are here, right? Or my one categorical variable split up by its categories. So now what we can do is we can compare distributions across categories, right? And so now we can compare distributions across categories. Okay. What's some information that we can get here? Almost all of the cars in the 4-cylinder category have a higher miles per gallon than any other categories, right? And so here, what you would do is you would just kind of see here, right? And so here, first thing I notice is that almost all 4 cylinders have a higher miles per gallon than any others. I say almost only because I feel like I maybe dipped my line up a little bit. Feel like it might have cut into here a little bit. We'd have to look at the numbers, right? But that's useful information, right? That whole lump is all above the rest of the 6 and the 8-cylinder engines, right? And so we also see that we have this outlier in the 8-cylinder engine with a really, really low miles per gallon That's got to be some sort of muscle car, right? Because high miles per gallon means you have good fuel efficiency, right? Yeah, how many miles do you get per gallon? Yeah, so high is good for fuel efficiency. So here, this is just some tank, a gas guzzling tank. And so we can look at the symmetry of the distributions, right? If there's symmetry around the median, then we likely have a normal distribution, right? And so we can talk about the distributions in terms of normal or skewed by looking at these box plots. Usually a go-to measurement that I compare is I look at the medians, right? How does this median compare to other values in this 6-cylinder box plot, for example? Right? Or if you wanted to, you could look at the minimum value is roughly the same as the maximum value in the 6 cylinders versus the 4 cylinders, right? Same deal. You could say that the maximum in the 8 cylinders is roughly the same as the median for 6 cylinders. So there's a lot of information that you could talk about here, right? And so it's really just comparing and knowing that you've got the minimum Q1, the median Q3, the maximum, and potentially some outliers, right, in the case of the 8 cylinders. And so it's just knowing what the components of the box plots are, and then you can compare those values, right, and just kind of look at how they compare across. And so where I leave you today is from How I Met Your Mother. Marshall's made a pie chart of his favorite bars and a bar chart of his favorite pies. Hey. Which is really funny. I do have a hard time kind of figuring out how to make a categorical variable of his favorite bars, but that's okay. It's all part of a joke. So it's okay. How do you count his favorite pies? So every day of the month, he changes his mind. Apple pie, cherry pie. Anyways, doesn't matter. But pretty funny. So anyways, I'll leave you there. And that's kind of the end of how do we visualize variables, both numerical and categorical, and how do we summarize them? Yeah, proportion of good factors. Yeah, exactly. I guess, yeah, he's got some sort of, but my image that I stole wasn't very good. So I can't, the percentage of, I don't know. But anyways, if you have any questions, let me know. Otherwise, I'll see you guys on Tuesday. And I'll stop this. See ya.